matrix number CN210335. My name is Kuhan Raj. My matrix number CN210335. As a representative from Group 23 CP Computer Programming Project, I'd like to introduce our project name OpAmp Calculator. Here are our group members: Muhammad Shazani Abid, Muhammad Faris Haikal, and Suraya Najiha. Well, here's our introduction for the project. An operational amplifier is an integrated circuit that can amplify weak electric signals. Two input pins and one pin make up an operational amplifier. Its primary function is to boost and output the voltage difference between the two input pins. Operational amplifiers are linear devices that have all the properties required for nearly ideal DC amplification and are therefore used extensively in signal conditioning, filtering, or to perform mathematical operations such as add, subtract, integration, and differentiation. Well, here's the problem statement of our project. The OpAmp calculations are different from one to another. Each of OpAmp consists of different types of circuit and components. So, the formula to get the voltage output is different. We created this project, which is the OpAmp calculator, to help the users to get the output easily. Well, the next slide is the project description. Project description is an overview of why students are doing a project, while also includes the objectives and goals of the proposed project. The objective is to help user in their study by having an OpAmp calculator. The goal of this project is to obtain a result on voltage gain and voltage output. Well, now is the flowchart of our project, which start from the start, and then the next go to the float RF, R1, A, win, V, out, R2, and V2. The next it will go to the chart type V, and then it will go to the print, where it will tell welcome to the OpAmp calculator, where it also given three options, which is the A, non-inverting OpAmp, B, inverting OpAmp, C, summing OpAmp, and then it will ask to please choose the circuit type. So after the user chooses the circuit type, it will go to the case, where here we use the switch case function to this project. And case A, if yes, it will say print this is a non-inverting OpAmp calculator. Down there it will ask to please insert the RF value, R1 value, and please insert the win value too. So at last it will show the result, and then it will print the value for voltage gain A, which is with the unit of V voltage, and the value for voltage output also with the unit of V. So lastly it will print. Well, here there are also the next case, which is case B. Case C depends on the user input, so whether they're choosing A or B or C option. So at last, if that user put a wrong input rather than these three options, it will show wrong input. So the user have to do back or just have to press the real option. Well, here's the pseudocode for the C++ programming code, which is we done before this. So first is start, and then second is float, etc. etc. It will go till the last one. It will show them as the 69th line end, and also there's a print wrong input. So there's also the stated case, which type of case, what are the functions we used in this coding. Well, finally these are the coding we did for our project. So there will be include starting from the first section, which is the extract, include IO stream until the return 0. So like I said, in this coding we use cout, scene, switch type, case, and float, int main, all the functions which we learned previously our previous labs were also taught by our lecturers. As the result of this coding, here it is. So for example, we choose the option A, non-inverting op-amp. So down there it will ask to please insert RF value 23, and then please insert R1 value 65, and then please insert Win value 12. So it will use the formula which we have also implanted in our coding to produce the answer, the output, which is the value for voltage gain A is 1.35385 volt, and the value for voltage output is 16.2462 volt. So it also have the input at the last, and here's the input. Here's the output. Well, that value of RF, R1 and Vin is based on the user who use our coding to get the value of voltage output and also the value of voltage gain. As a conclusion of this project, this program will be helpful to any student or researcher because this program designed to build our calculator in the most convenient way for people to use it. Our calculator is a user-friendly for people to understand a basic knowledge of 3 types of operational amplifier and a flow of the programs. For our flowchart, the function that we have used in these programs is switch case. In our program, we had shown the ups and downs of making in the terms of the knowledge that we had applied in the class. For example, in coding, we had used functions to make the coding more easily to understand the instruction given by condition that we have applied. Our program objectives are easy to understand, modify and extend. We use simple calculations and a basic fundamental to create an op-amp calculator. A problem may have many correct solutions, but some are more efficient than others. We hope that our project will help to facilitate the work of those around. As a representative from Group 23 Computer Programming Project, I would like to thank everyone for viewing this video and presentation. Thank you so much.